Hello everyone, in this video I'm going to show you how to identify possible split points to build a decision tree where the outcome variable is binary. The decision trees generated in binary variables are called classification trees. As I mentioned earlier, the CART algorithm uses a recursive partitioning process to split the cases into pure subsets to build the tree. In a classification problem with a binary target variable, a subset is considered pure when it contains cases that all belong to the same class. For example, 100% of the cases belong to case 1, 0% of the cases belong to case 0. A subset with the highest degree of impurity, on the other hand, is when half of the cases belong to one class and the other half belong to the other. Impurity is therefore measured by how well the two classes are separated. In order to build a decision tree, we need to understand the possible split points on each predictor variable and next how the CART algorithm determines the optimal splits. Let's start with first identifying possible split points. On the screen, you see the data from HELOC example that I introduced you in the previous video. In this example, the bank manager has collected data from 500 past customers that include the customer's age, sex, income, and whether or not the customer responded to the HELOC offer. HELOC equals 1 if responded, 0 otherwise. And here on the screen, you see a portion of 20 randomly selected cases from this dataset. These 20 cases as a training dataset is going to be used to develop a classification tree with two predictor variables, age and income. The CART algorithm uses the midpoints between consecutive cases of the predictor variable as possible split points. To find the midpoint, first we need to sort age variable in ascending order. Let's copy paste the age here and then choose data and then choose sort, and here smallest to largest and click OK. Here in this column, you see that some of the values have multiple occurrences. But for determining split points, each value only needs to appear once in the column. Therefore, we are going to delete multiple occurrences. Here we have double 39, and then we have 44, and then here we have 47. Now we are good. After we sort the data, we are ready to calculate the split points. We are going to use midpoint formula, which is start with an equal sign, 23 plus 24 divided by 2. 23.5 is our first split point. Second point is 24 plus 25 in the parentheses and then divided by 2. This is our second split point. Now we can drag down this formula to find the other split points. The last one is 62 plus 63 divided by 2, which is 62.5. Now we are going to repeat the same steps for income variable. Here let's copy paste the income variable and then next sort the data. And let's see if there are multiple occurrences of the same value. There is no, so we can start using midpoint formula. Open the parentheses, 4,000 plus 11,000 divided by 2. And now we can drag down this formula. And now we need to delete the last one because last one refers to an empty cell. And these are the possible split points for the income variable. After identifying all the possible split points on the two variables, the next step is to find an optimal partition that minimizes impurity into two resulting subsets. And remember that impurity of a node in a decision tree is measured by how well the classes are separated from one another. There are several ways to measure impurity, including Gini impurity index, entropy index, and chi-square test. I'm going to use Gini impurity index to show how to identify optimal split points for producing a classification tree.